Hey folks, today I'm going to show you how to fine-tune Stability AI's SDXL model using Replicate and using the Replicate Fine-Tune API. So here we are on replicate.com, and there is a collection here of SDXL fine-tunes. So this is the type of thing that we're going to be able to make, and I'm going to show you how to do it. Some examples first. So we've got a Barbie fine-tune, so a fine-tune based on the Barbie movie. And in this example, you can prompt a photo in the style of TOK, TOC. TOC represents token and it represents the trained concept. So in this situation, it is the Barbie movie style. If you go back, we've got SDXL Vision Pro, and this is the fine-tune I'm going to talk through. I'm going to show the training images that are used and the API that you need to call and how to call it and what the options are. But this is an SDXL Vision Pro fine-tune I've already put together, and our prompt is a photo of Gandalf wearing a TOC VR headset. Again, TOC in this case is the trained concept. So it is the Apple Vision Pro headset. That's what we trained on. And you can see we've got our nice picture of Gandalf wearing an Apple Vision Pro. And if we go to the examples, you can see we can also prompt for the Vision Pro by itself. We can have other people wearing it. We can even have cats wearing it, or we can have medieval paintings of it. So there's a lot of flexibility with the outputs of these fine tunes. And just some more examples. We've got a fine-tune based on the Tron Legacy movie. There's one based on the GTA 5 art, some 70s sci-fi, Sonic 2 pixel art, Loteria cards, and some architectural photography. One of the most important things to get right with your SDXL fine-tune is the training images. So the images that you use to create your fine-tune. In this example, we are covering an Apple Vision Pro. So we need to have images that show the Apple Vision Pro in all of the different ways you might want to prompt for it. So people wearing it, having the Vision Pro on display. What does it look like from the front, from the sides, in different modes? Typically, you need at least 5 images, but I've found 20 to 30 images works pretty well. So here are the training images that I've used for the SDXL Vision Pro fine-tune. So we've got someone wearing it. You can see them using it. We've got the Vision Pro just by itself on a mount. And you should be familiar with these images if you've seen any of the Apple marketing. So there's some close-up pictures, there's some pictures in use, importantly, some pictures showing the rear of the Vision Pro, some more use cases, just the Vision Pro by itself with the battery pack, someone using a Vision Pro. As you can see, we've got a variety of sort of marketing style images, and that's it. I've used 18 different images to train the Vision Pro. Now that we've got our training images ready, we can start our training. Before we start the training, we need a holding model on replicate.com. That's easy enough. We go to replicate.com/create. And from here, we can create the model. We just need to give it a name. So let's call this one SDXL demo. And we need to choose whether it's public or private, and we need to choose the hardware that it's on. Now, it defaults to the hardware that the original model that is being fine-tuned uses. So Stability AI SDXL uses the NVIDIA A40 large hardware. And that's a good choice because it's a good balance between cost of running the predictions and time taken to produce the images. So we'll create that. And now you'll find we have got our F of R SDXL demo, and this is our holding model, which is where Replicate will put our fine-tuned SDXL once our training completes. Before we can start our training, we will need our Replicate API token, which we can find on replicate.com account/API tokens, and you can see your default token, which you can then copy, or you can create a new token just for fine tunings and create it here. So let's copy this token. So there are a few different ways that we can start our training. So if we go to Docs and then down to Client Libraries, you can see on here we have a number of different clients that you can use to start your training. So there's a JavaScript client, Python, Swift, Elixir, Go, and also some community maintained clients. The main ones to pull out here might be Replicate Ruby and Replicate Rails. I'm going to show you quickly how you might do this using the Replicate JavaScript Node.js client, and then also we'll take a look at the new Replicate CLI tool. So this is the Replicate JavaScript library, which you can install using npm install replicate. You can import the client and set up Replicate by passing in your auth token. And then down here, this is all of the details of the API. And then we've got an example of how to do training. So replicate trainings create. Looks like this. So we've got model owner, model name, version ID, and options. So I've put together a little gist to show how this would look exactly for the SDXL fine tune. So this is a GitHub gist that I've put together to show you how you can call the Replicate JavaScript client to kick off an SDXL fine tuning. So as you can see, we're importing the client, we're configuring the client by passing in our API token, and then we're calling replicate trainings create. And then we've got our model owner, Stability AI, our model, SDXL, and the latest version of the model, which starts A00. Then we've got our training options. And the first option is the destination, which is your username and model. So f/SDXL demo in this example. And then our input parameters. And there's quite a few different input parameters you can use. But the minimum that you need is a set of input images. And this is a URL to a zip of those images. So all of those Vision Pro images that we had a look at before, I've zipped them up, put them online, and referenced them here. Then to call this script, you simply call node train SDXL.js. And that will kick off the training and console log out a URL where you can go and check out the training progress. So one other way that I'm going to show you how to kick off training is by using the new CLI for Replicate. And you can find this at github.com/replicate/CLI. And this is a pretty new tool. It's currently only 3 days old, but it supports trainings. So this is the CLI. This is sort of how you would use it. You export your token and then you call replicate run. In this case, it's doing an inference. So it's creating an image of a rainbow colored corgi. To install it, if you're on a Mac, you can use Homebrew and you can call brew tap replicate/tap or brew and then brew install replicate. Or you can build from source. And down here, we've got an example of how to fine tune a model. And this example is an SDXL one. So you call replicate train, then you can pass in your destination. So in this example, it's Matt's SDXL Dream Booth --web. Simply says, once this is completed, open up the browser and take me directly to the prediction that's running or the training that's running. Then this is training a replicate SDXL model with the input images. So it's passing in a local zip file. And this is using another option that we haven't talked about yet. If you're fine tuning a person's face, then there's some extra parameters you can pass in to make the tuning a bit better. So use face detection instead. True is just saying segment these input images based on faces to improve the training quality. So let's give this a go to kick off our SDXL demo training. So I've got the replicate CLI installed. So if I do replicate-h, I can see the commands that I can run, and we are going to call replicate train, or which is short for replicate training create. So replicate train, and then the model that we're going to train is stability AI / SDXL, and the destination that we set up will be f of r / SDXL demo, and then the input images that we're going to use I have uploaded here. So let's kick off this training. So you can see we now have a URL that shows our training has started. So let's check that out. So this is our training that we created, and it lives at this URL. And you can see here are the input images that we passed in, and this training is now completed. And down here we can see the logs of what it did during the process. And we can see that this one took 569 seconds, which is not too bad. So that's less than 10 minutes. So here we have all of the example images that we passed in, our training images. You can see all of those file names. If we scroll down a bit further, we can see that it generates some captions for each of these. So it starts with the same prefix. So this is our caption prefix, and photo of TOK is the default caption prefix. That works for our training because everything we passed in was a photo of a Vision Pro. So it's working. If we were doing something that was more based on the style, we might change our caption prefix to be in the style of TOK. But for now, we can see wearing a brown shirt, wearing a virtual reality headset. These are good captions for our training images. And we'll cover the options in a bit more depth soon. So then it upscales all of the images and resizes them to the right size. So the default size of training images that this fine-tuning uses is 768 by 768, but that is also another parameter you can change. And these are the final captions that it's going to train on, where the TOK token has been replaced with SO/S1 special params. And here it's started the training. So it's going to do 1,000 steps, and it reckons it's going to take about 7 minutes and 50 seconds at 2 iterations per second. 1,000 steps is the default, and for images 5 to 30, that is a good number of steps that's going to get you good results. So we've tested these default parameters and we're pretty happy with the outputs that you'll get. But again, you can change that too. So let's scroll down and we get to the bottom when it completes all of those 1,000 steps, and at the bottom we see the 3 files that we can download. So our LoRa safe tensors, our embeddings, and our special params. So if we hit download, we'll get a zip of those 3 things, and we can use those locally, or we could incorporate them into some code that's using Hugging Face diffusers. You can do what you like with those weights. So this is our output model, which is now immediately available to create images with. So it's a SDXL demo where we created it. It's asking us to add some descriptions and examples, which we can do. Let's try kicking it off with a photo of a talk wearing a VR headset. And we'll see how that does. Other parameters you can pass in: negative prompt, image for image to image, mask, an image for in painting, width and height, number of outputs, which is 1 to 4, scheduler, number of steps, guidance scale, prompt strength, which is used in image to image, Seed, if you want to keep that the same between generations. The refiner, whether you want to use a watermark or not. And then this is a really important option in the fine tuning, which is basically saying how strong is the fine tune, how much is being used. So we're at 60% here. If we took it all the way down to 0, then this would be effectively the same as if we hadn't trained it. And if we take it up to 1, that's the maximum. But sometimes at the maximum, you can get some weird distortions. So you want to try and find the right balance. But essentially, if you're creating an image and you're using your top token and you're getting too much of a style or too much of something, dial it down. And if you're not seeing enough of it, dial it up and experiment with the LoRa scale. So after doing a fine tuning, when creating your images, play with the LoRa scale and play with the prompt and use those together to try and make something that's really good. And how's our image? Well, there we go. There's someone wearing a Vision Pro. It's got a strange extra head strap and it's not quite identical, but that's pretty good for a quick training. Let's see if we can improve on this image slightly. So let's change photo of ATOC to a photo of ATOC VR headset. A man is dancing. And let's try an expert ensemble refiner. So the refiner model improves the fine details of your image. And if you use the expert ensemble mode, then the base model will hand off to the refiner after a certain percentage. And the default is 80%. The refiner model hasn't been fine-tuned and isn't using our LoRa. So if you make this fraction too large, then you might end up losing some of that style or object because the refiner model doesn't know about it. So it's going to be responding to the prompt in a different way. But you can also use the refiner just to improve the details slightly by just using a small fraction. So I've been doing 0.95, which I think works pretty well. The refine steps is used if you want to use the base image refiner, which is a slightly different technique where the base model creates the full image and then you run a few steps afterwards to do the refiner. And let's set the LoRa scale to 0.7 and run that. Now, one more trick that I've found, which is sometimes you'll train a concept and you'll say a photo of TOC and you don't see TOC coming through or the style's not there. And I found that if you tweak your prompt to include a keyword that nudges it closer to the sort of thing you're after, then you're more likely to see your fine-tuning coming through. So as an example, with a Barbie fine-tune, if you say subtle pink or pink at the end of the prompt, or if it's Tron, if you say neon or sci-fi or futuristic, or with the Vision Pro, if you say VR headset, then that should be enough to push the diffusion process to include or use your fine-tuning, and you should get good results. So let's have a look at this image. So there's a guy kind of dancing. It's okay. When you find an example you're happy with, you can add it to the example gallery, and then anyone else who comes along who wants to give this a go can copy your settings easily and see how to use the model. Now let's discuss some of the other training options that you can use when you do your SDXL fine-tuning. So if you go to the SDXL model, and if you scroll all the way down to the README, in the README we have a section on fine-tuning, and we have details on the training input. So far all we've used is input images, which is the zip or tar file containing the images. And I'm just going to touch on each of these, go through them. I might skip some of the ones that are less relevant, but let's go through them one by one. So seed This essentially makes your training reproducible. So same input images, same seed, you'll get the same LoRa output. And that's good. If you're just wanting to tweak settings and do some comparisons, you can set a seed and do that. Resolution, this currently says 512. I think we've bumped that up to 768. You can increase that to 1024. You can play with different sizes to see what gives you the best training results. If you go too big, you might get an out of memory issue. Train batch size, so that defaults to 4. Number of training epochs and maximum train steps. So maximum train steps overrides the number of epochs. So we have 1,000 steps by default. If you set that to none, then the epochs will take over and you can define your epochs. Epochs are really useful if you've got a really large set of training images that you need to pass through, and you need to make sure that you're going to pass through X number of times. Is LoRa? So by default, all of these trainings are LoRa trainings. But you can set it to false. And if you set it to false, that means that you will do a full model fine-tuning, which will touch all of the weights in the model. Unit learning rate is set to 1e-6 to 1e-5. TILR, which is the textual inversion learning rate, defaults to 3e-4. LoRa learning rate is set to 1e-4. And this is the one that you might want to try and play with if you're using, if you're training styles. So styles can get away with a faster learning rate. You don't necessarily want the training to incorporate all of the details in the images. You're actually just trying to get a flavor or style of your training set. So by increasing the training rate, then it's sort of, it has the effect of ignoring some of the details. So I've tried different values from 2, 3, 4, e⁻⁴. You can experiment with that. Learning rate scheduler has two options. You can set it to a constant learning rate or a linear learning rate. We've got token strings, so that's our TOK. You can change that to whatever you want. TOK is our default, so that's why I've used it. We could have changed that to Apple_Vision_Pro if we wanted to. Caption prefix. This is a really important one. So our default is a photo of TOK, and this is what's going to be the start of your caption, your generated caption that gets trained on. So it's really important that this accurately represents the thing that you're training. So you might have in the style of TOK, a photo of TOK. For the Apple Vision Pro, we could have done a photo of a TOK VR headset. And that would have helped specify that TOK is the VR headset in each of those images. Mask target prompts is a way of automatically generating a mask on your training images to focus the training on the bits that matter. So you can pass in a prompt to do that. So if you say photo of a dog and you pass in lots of pictures, it will try and mask just the dog in each of those pictures so that the training focuses on just the dog details and not other things like all of the pictures were in a certain style. And then crop based on salience. If you want to crop the image to a target size based on the important parts of the image, set this to true. So this essentially says when you do the cropping, keep the most important part of the image. Use face detection instead. So rather than cropping based on salience, you can use a face detection algorithm, which the model does automatically. It will work out what face is there, crop to it, and focus on that for the training. And those are all of the options that we currently have for fine-tuning SDXL. Thanks for watching. I hope you found that interesting. And if you liked the video, don't forget to like and subscribe. Thanks very much.